We are Group 6 and we are going to discuss how a light sensor works and how it was made.
I'm Marjorie G. Marcaida and I will introduce to you about a light sensor. This is Rosen Perez and she will discuss to you about the objectives of a light sensor. Rain, Raven Lanes to summarize you about how a light sensor works and Emor Makatangay to discuss about the functions of a light sensor. What is a light sensor? A light sensor, as its name suggests, is a device that is used to detect light. A light sensor is a passive device that converts this light energy, whether visible or in the infrared parts of the spectrum, into an electrical signal output. Light sensors are more commonly known as photoelectrical devices or photosensors because they convert light energy or photons into electricity or electrons, and the light sensors detect variance in the field of light sensitivity and convert this into electrical signals, which then produce a specific electrical output. There are many different types of light sensors, each of which works in a slightly different way. A photocell or photoresistor, for example, is a small sensor that changes its resistance when light shines on it. They are used in many consumer products to determine the intensity of light.
The prime objective of this light source is first to build a theoretical design to verify that it works and to provide a physical platform for debugging it if it does not. Second is to make a prototype that will be activated by light calling sensor. And the third is to learn and know the application of electronics in the field of electrical engineering.
The summary. A light sensor is a mechanical device sensitive to light, temperature, radiation level that transmit a signal to a measuring or controlled instrument. As electronics seamlessly weave their way into our lives, sensors play an increasingly important role. Light sensors are among the simplest and cheapest sensors, allowing their inclusion into numerous consumer products ranging from night lights to cameras. Light sensors also advance through technology with its use. There have been advancements in light sensor technology through the years, especially in microscopic and macroscopic areas. One major advancement was that 2 times to 4 times increase in sensitivity to light, which makes the sensors more precise. These applications knows light sensors best when they are used in motion detector devices and also light detection. It is also important that these devices compromise from the final design due to differences in materials, processes, and design fidelity. It is possible that the prototype may fail to perform acceptably whereas the prototype design may have been done. The prototype work accordingly with the motion. A light sensor has an eye, or the LDR, that detects the motion. When the motion goes past the eye, the light registers on the device. The circuit uses a light-dependent resistor, or the LDR, as a sensor and three transistors to amplify the signals from the LDR and drive the relay, which does the switching.
As you can see from the circuit diagram, in the input of the circuit there is trimmer R7. This is the trimmer R7 connected in series with the LDR in such a way as to form a voltage divider. When light falls on the LDR, it causes its resistance to change, and this causes the voltage across the LDR to change accordingly. These voltage changes are used to change the state of the transistor, switching it on and off. The output from TR2 drives transistor 1, and this turn in transistor 3, which drives the output relay. This is the transistor 3. The diode D1 protects the transistor from the back EMF that is produced from the relay coil when it is turned off. The diode is in the middle of the capacitor and the relay. The trimmer R7 or the potentiometer adjusts the sensitivity of the circuit, so it is possible to use it under widely different conditions. The circuit operates from 9 to 12 volt DC power supply, and the relay contacts are rated at 250 volts 2 ampere. This is our prototype, and this is how it works. As you can see from our prototype, when there is light, the LED is off. And when the light is removed, the LED will turn on.
After we have made a light sensor, we have concluded that there is a wide variety of optical sensors available in small packages at reasonable prices. Passive solutions have been serving consumers for decades in nightlights and digital still cameras. Active solutions have increased the range and usefulness of ambient light sensors. Typical active solutions integrate a phototransistor or a photodiode with a current amplifier. When greater resolution, low light capability, power supply rejection, or a disassembling function would be useful. Devices such as those in the ISL family extend the usefulness of typical ambient light sensors.